Graphics Programming Introduction. The following topics are focused in this chapter: Java 2D rendering model, strokes and fills, geometries, fonts and text layout, transformations, using color and hardware acceleration and active rendering techniques. Java 2D rendering model. The graphics 2D object, which extends java.awt.graphics and its state attributes at the same time. The Java 2D rendering process is restricted through the graphic 2D object. The graphics 2D state attributes like line styles and transformations are manipulated to graphic objects when they are offered. Setting the graphics 2D context and then calling one of the graphics 2D rendering methods can give text, shapes, or image like draw or fill. Interfaces and classes. Interfaces: composite, composite context, paint, paint context, and stroke. Classes: affine transform, alpha composite, basic stroke, color, gradient paint, graphics 2D, and texture paint. Rendering concepts. To render a graphic object using the Java 2D API, setting up the graphics 2D context and pass the graphic object to one of the graphics 2D rendering methods are needed. You can modify the state attributes that form the graphics 2D context too. Vary the stroke width. Change how strokes are joined together. Set a clipping path to limit the area that is rendered. When objects are rendered, translate, rotate, scale, or shear objects. Define colors and patterns to fill shapes with. Specify how multiple graphics objects should be composed. Several methods for adding and modifying attributes in the graphics context are defined by graphics 2D. The representation of an object is taken a particular attribute like a paint or stroke object. If you alter an attribute object that is part of the graphics 2D context, you need to call the appropriate set method to notify the context. Rendering process. While rendering a graphic object, the geometry, image, and attribute information are combined to calculate which pixel values must be changed on the display. The rendering process for a shape can be broken down into 4 steps. If the shape is to be stroke, the stroke attribute in the graphics 2D context is used to generate a new shape that encompasses the stroke path. The coordination of the shape path are transformed from user space into the device space according to the transform attribute in the graphics 2D context. The shape's path is clipped by using the clip attribute in the graphics 2D context. The remaining shape, if any, is filled using the paint and composite attributes in the graphics 2D context. Rendering text is similar to rendering a shape. Images are handled differently. Transformations and clipping operations are performed on the image bounding box. Strokes and fills. Strokes. A basic stroke object is used to define the stroke attributes for graphics 2D context. It defines characteristics such as line width, end cap style, segment joint style, and the dashing pattern. In order to set or change the stroke attribute in the graphics 2D context, you call setStroke. The graphics 2D rendering methods adopt the stroke attribute, which are draw, draw arc, draw line, draw oval, draw polygon, draw polyline, draw rect, and draw round rect. When one of these methods is called, it renders the outline of the specified shape is rendered. The stroke attribute defines the line characteristics, and the paint attribute defines the color or pattern of the mark drawn by pen. For example, when draw my rectangle is called, the stroke is applied to the rectangle's outline. The stroke outline is converted to a shape object. The paint is applied to the pixels that lie within the contour of the outline shape. Specifying stroke attributes. To set the stroke width, you create a basic stroke object with the desired width and call set stroke. Wide stroke equal to new basic stroke of 12.0f. G2.setStroke of wide stroke. To set the join and end cap styles, you create a basic stroke object with the desired attributes. Round stroke equal to new basic stroke of 4.0f, basic stroke dot cap underscore round, basic stroke dot join underscore round. G2 dot set stroke of round stroke. While creating a basic stroke object, you can specify the two parameters that control the dashing pattern. Dash, an array that represents the dashing pattern. Dash underscore face, an offset that defines where the dashing pattern starts. The dashing patterns as explained in this below diagram. Fills. The fill attribute in the graphics 2D context a paint object represents. Addition can be done paint to the graphics 2D context by calling setPaint. When a shape or glyph is drawn, the paint is applied to the pixels which lie inside the shape that can represent the object's stroke outline. The paint is applied to the pixels that lie within the shape's counter when a shape is filled. Simple solid color fills can be set with the setColor method. To fill shapes with more complex paint styles such as gradients and textures, use the Java 2D Paint classes Gradient Paint and Texture Paint. When fill is called to render a shape, the system determines what pixels comprise the shape, gets the color of each pixel from the paint object, converts the color to an appropriate pixel value for the output device, writes the pixel to that device. Batch processing. The Java 2D API processes the pixels in batches to streamline. A batch can be either a contiguous set of pixels on a given scan line or a block of pixels. This batch processing is executed in two steps. To create a paint context, the paint object createContext method is called. The paint context stores the contextual about the current rendering operation and the information necessary to generate the colors. User space and device space are filled with the bounding boxes of the graphics object. It passes createContext method. Colors are generated in the color model. Using user space into device space transforms the maps. To get the color model of the generated paint color from the paint context, the getColorModel method is called. The getRaster method is then called repeatedly to get the raster which contains the actual color data for each batch. This information is moved to the next stage in the rendering pipeline, which draws the generated color using the current composite object. Specifying fill attributes. The paint attribute in the graphics 2D context determines the fill color or pattern that is used when text and shapes are rendered. Filling a shape with a gradient. The gradient paint class provides an easy way to fill a shape with a gradient of one color to another. To fill a shape with a gradient of one color to another, create a gradient paint object. Call graphics2d.setPaint. Create the shape. Call graphics2d.fill of shape. For example, a rectangle is filled with a blue-green gradient. Gradient paint GP equal to new gradient paint of 50.0f, 50.0f, color.blue 50.0f, 250.0f, color.green. G2.set paint of GP. G2.fill rect of 50, 50, 200, 200. Filling a shape with a texture. The texture pane class provides an easy way to fill a shape with a repeating pattern. To fill a shape with a texture, create a texture paint object. Call graphics2d.setPaint. Create the shape and call graphics2d.fillOf shape. Geometries. The Java 2D API provides several classes that define common geometric objects such as points, lines, curves, and rectangles as part of java.awt.geometric package. The Java 2D API geometries such as general path, arc 2D, and rectangle 2D implement the shape interface defined in java.awt.shape. A new interface, path iterator, defines methods for retrieving elements from a geometry. Interfaces and classes. Interface, path iterator, shape. Classes, arc 2D, area, cubic curve 2D, dimension 2D, ellipse 2D, flattening path iterator, general path, line 2D, point 2D, quad curve 2D, rectangle 2D, rectangular shape, and round rectangle 2D. Geometry concept. An implemented shape class of an instance is a shape interface, general path, or rectangle 2D dot float. A shape's counter is referred to as its path. A shape's path can also be helpful to define a clipping path. A general path is a shape that can be used to represent any two-dimensional object that can be constructed from lines and quadratic or cubic curves. Constructive area geometry. Constructive area geometry is the process of creating new geometric objects by performing Boolean operations on existing objects. The Java 2D API, a special type of shape called area, supports Boolean operations. You can construct an area from any shape. Area which are supported by the following Boolean operations: union, intersection, subtraction, and exclusive OR. Bounds and hit testing. A fully enclosed geometry is a bounding. It is a box rectangle. The shape interface defines two methods for retrieving a shape's bounding box, namely getBounds and getBounds2D. Shape also provides methods for determining whether do or do not. A specified point lies within the bounds of the shape. A specified rectangle lies totally within the bounds of the shape. A specified rectangle intersects the shape. Combining areas to create new shapes. Construct complex shapes from simple shapes such as circles and squares. Area can acute need to create a new complex shape by combining areas. Using shapes, construct the areas to be combined. Call the appropriate Boolean operators: add, subtract, intersect, and exclusive OR. Pair constructed from circles. The body of the pair is constructed by performing a union operation on two overlapping areas, a circle and a oval. Each leaves are created by performing an intersection on two overlapping circles and then join into a single shape through a union operation. Overlapping circles are also used to construct this term through two subtraction operations. Fonts and text layout. The Java 2D API provides text-related classes, that is font and text layout, which assist fine-grained font control and sophisticated text layout. Interfaces and classes. Interfaces: multiple master, open type. Classes: font, font render context, glyph justification info, glyph metrics, glyph vector, graphic attribute, image graphic attribute, line break measurer, line metrics, shape graphic attribute, text attribute, text hit info, and text layout. Font concept. An instance of a font face is represented by a font object. This font face are taken from the collection of font face available on the system. The following are the names associated with a font. A font object's logical name is a name mapped onto one of the specific fonts available on the platform. A font object's family name is the name of the font family, which determines the typographic design across several faces. A font object font face name refers to an actual font installed on the system. Access information about a font through the getAttributes method. A line metrics object encapsulates the measurement information associated with a font, such as its ascent, descent, and leading. Ascent means the distance from the baseline to the ascender line. Descent indicates the distance from the baseline to the descender line. Leading expresses the recommended distance from the bottom of the descender line to the top of the next line. Text layout concept. It must be properly shaped and positioned using the appropriate glyph and ligatures. This process is referred to as text layout. The text layout process involves before a piece of text can be displayed. Shaping text using the appropriate glyph and ligatures. Properly ordering the text. Measuring and positioning the text. Shaping text. A glyph is a visual representation of one or more characters. The shape, size, and position of a glyph, the content holds the authority of different glyphs, can be used to represent a single character or combination of characters depending on the font and style. Ordering text. Logical order is the storehouse of encoding. This encoding is used as a Unicode character. No similarities can be found in the logical order and the visual order. In this visual order, the corresponding glyphs are displayed. The visual order for glyphs in a particular writing system is called script order. Measuring and positioning text. Text is always displayed by using multiple fonts and styles such as bold or italic. To properly position, measure, and render text, you need to keep track of each individual character and the style applied to that character using text layout. Supporting text manipulation. To allow the user to edit the text that is displayed, you must be able to display a caret that indicates where new characters will be inserted when the user enters text. Move the character and insertion point in response to user input. Detect user selections. Highlight selected text. Managing text layout. The text layout class supports text that contains multiple styles and characters from different writing systems, including Arabic and Hebrew. Text layout simplifies the process of displaying and measuring text. Text layout is designed so that there is no significant performance impact when it is used to display simple monodirectional text. The text layout class manages the positioning and ordering of glyphs for you. You can use text layout to layout monodirectional and bidirectional text, display and move carets, perform hit texting on text, highlight text selection. Transformations. The graphics 2D context used to transform objects since it has a transform from user space to device space during rendering. Rotation or scaling are the additional transformations. Graphics 2D context allows other transforms to perform additional transformations. Graphics 2D provides several different ways to modify the transform. The simplest is to call one of the Graphics 2D transformation methods rotate, scale, shear or translate. An affine transform performs a linear transformation such as translation, scaling, rotation or shearing on a set of graphics primitives. When a transform is concatenated with an existing transform, the last transform specified is the first to be applied. To concatenate a transform with a current transform, you pass an affine transform to graphics2d.transform. The setTransform method overrides a graphics 2D object current transform, which is needed for other purposes such as applying a scaling transform to adjust for printer resolution, painting a J component at non-zero translation from its parent's origin, scaling up a component for easier viewing. Any other situation in which the supplier of a graphics 2D object might want to transform the rendering for effect. Affine transform AT equal to G2D.getTransform, G2D.transform of, G2D.draw of, G2D.setTransform of AT. Affine transform. When affine transforms are rendered, they are used to transform text, shapes and images. You can also apply transforms to font objects to create new font derivations. An affine transformation performs a linear transformation on a set of graphics primitives. Affine transformations are based on two-dimensional matrices of the following form: AC Tx BD Ty, where x dash equal to Ax plus Cy plus Tx and y dash equal to Bx plus Dy plus Ty. With the effective creation of series or pipeline of transformation, it can be clubbed together. This combination is referred to as concatenation. A transform can also be pre-concatenated with an existing transform. Affine transform provides a set of convenience methods for constructing affine transform objects: getTranslate instance, getRotate instance, getScale instance and getShear instance. Using color. Color imaging is one of the fundamental components of any graphic system. The key color management classes in the Java 2D API are color space, color and color model. Three separate numerical values or components are used for measuring colors in a system. The system is represented by a color space. The color space class contains methods for converting between the color space and two standard color spaces CIEXYZ and RGB. A color defined in terms of its components in a particular color space. It is a fixed color. To draw a shape in a color such as red, you pass a color object representing that color to the graphics 2D context. Color is defined in the java.awt package. A color model describes a particular way that pixel values or mapped to colors. It is typically associated with an image or buffer image and provides the information necessary to correctly interpret the pixel values. Color model is defined in the java.awt.image package. Classes: color space, ICC underscore color space, ICC underscore profile, ICC underscore profile gray, and ICC underscore profile RGB. Color concepts. A color model is used for interpreting pixel data in an image. The color model is associated with an image. It encapsulates the data and methods necessary for translating a pixel value to and from its constituent color components. Color. The Java 2D API provides two color models in addition to the direct color model and index color model. Component color model and handle an arbitrary color space and an array of color components to match the color space. This model can be used to represent most color model on most types of graphics devices. Pack color model is a base class for models. These models represent pixel values that have their color components embedded directly in the bits of an integer pixel. Color space. A color space object represents a system for measuring colors, typically using three separate numeric values. Color space provides methods that transform colors in a specific color space to and from sRGB and to and from a well-defined CIEXYZ color space. All color space objects must be able to map a color from the represented color space into sRGB and transform an sRGB color into the represented color space. The methods used for this process are toRGB and fromRGB. toRGB transforms a color in the represented color space to a color in sRGB. fromRGB takes a color in sRGB and transforms it into the represented color space. Describing colors. A description of a color is provided by the color class in a particular color space. The value of the color components and a color space object are the integrate part of an instance of color. The color class has a number of methods. It supports a proposed standard RGB color space called sRGB. The color space class defines the methods toRGB and fromRGB so that developers can easily retrieve colors in this standard space. By combining different amounts of red, green and blue light colors on a computer screen are generated. Therefore, using an RGB color space is the standard for imaging on computer monitors. Color matching. The API has an accurately specified color. At once, it must bring out that color on an output device as a monitor or printer. Achieving consistent and accurate color requires not only input colors but also output devices be profiled against a standard color space. Mapping colors through sRGB and CIEXYZ. The Java 2D API speaks of to RGB and CMYK as color space types. A particular model of monitor combined with its particular phosphors defines its own RGB color space. The International Commission on Illumination has determined standards for the device-independent specification of color. Attaching information to the space is one way to map between color space. This attaching information elaborates how the device-dependent space relates to the device-independent space. This additional information is called profile. A commonly used type of color profile is the ICC color profile as defined by the International Color Consortium. Graphics 2D provides rendering methods for shapes, text and images. Draw strokes a shape's path using the stroke and paint objects in the graphics 2D context. Fill fills a shape using the paint in the graphics 2D context. Draw string renders the specified text string using the paint in the graphics 2D context. Draw image renders the specified image. Drawing a shape. The outline of any shape can be rendered by the graphics 2D draw method. When a shape is drawn, its path is stroked by the stroke object in the graphics 2D context. To render outline of shape, create a basic stroke object. Call graphics2d dot set stroke. Create the shape. Call graphics2d dot draw of shape. Filling a shape. The graphics2d dot fill method can be recycled to fill any shape. When a shape is filled, the area within its path is rendered with the graphics2d context current paint attribute, a color, texture paint or gradient paint. To fill a shape, set the fill color or pattern on the graphics context using graphics2d.setColor or graphics2d.setPaint. Create the shape. Call graphics2d.fill to render the shape. Example: public void paint of graphics G. Open bracket. Graphics 2D G2 equal to graphics 2D G. G2 dot set paint of color dot green. Rectangle 2D R2 equal to new rectangle 2D dot float of 25, 25, 150, 150. G2 dot fill of R2 bracket closed. Rendering text. To render a text string, you call graphics2d dot raw string, passing in the string that you want to render. Rendering images. To render an image, you create the image and call graphics2d